Okay, so we're going to walk through this probability rules worksheet. It's talking about Tootsie Pops. They come in various flavors: chocolate, cherry, orange, grape, and raspberry. If you pick one, what's the probability it's raspberry? I'm just going to sneak in a table here. I have chocolate, cherry, just converting everything to decimals, orange, grape, and then the rest is raspberry. So these should all add up to 1. So what I'm going to do is figure out how much they all are together and then subtract from 1 to find raspberry. Because if these are all of the possible outcomes, these are all the possible flavors, it should equal 100% or 1. I get 0.83, and 1 minus 0.83 is 0.17. So that means that my raspberry is 0.17. Okay, if it is orange or grape, I know that or means add because I need to increase my probability from just orange to now orange or grape. So orange is 0.14 and grape is 0.12, so orange or grape is 0.26. Okay, not chocolate means everything except chocolate. So everything except chocolate. Okay, this is the complement rule. It's like the probability of not chocolate is 1 minus the probability of chocolate. Okay, so if you pick 3 Tootsie Pops, so now I'm dealing with this multiplication rule because I'm picking more than just one. And so I've got these 3 Tootsie Pops, and none of them are chocolate, meaning all of these are not chocolate. And we just found the probability of not chocolate up here in 1C. Not chocolate was 0.65. So it's like saying I want not chocolate and then also another not chocolate and another not chocolate. So this is a multiplication rule. And another, all of that has to occur at the same time for it to be all not chocolate. And that's 0.275. Or you could also do 0.65 to the 3rd power. That's the same thing. Okay, the 3rd one is the first cherry you pick. So I'm picking 3 Tootsie Pops. The 3rd one is the first cherry. So this one's cherry, but it's the first cherry, meaning that these ones are not cherry. I don't care what they are as long as they're not cherry. So cherry is 0.22. Not cherry should be 1 minus 0.22 or 0.78. Not cherry. And all of this must be true at the same time, so we multiply them. And you get that 0.1138. 1338, excuse me. Alright, the next one. The first one is the only raspberry. So if I look at these 3, this one's raspberry, but it's the only raspberry, meaning these ones are not raspberry. So raspberry we found out was 0.17. Not raspberry would be everything else, 0.83. It's kind of like saying P, raspberry, that's our success, and Q, that's our fail. So this should give us 0.1171 when we multiply. All right, now these ones are a bit tough. At least one is orange. So we've got these 3, and I want one of them to be orange, or 2 of them to be orange, or 3 of them to be orange. The one thing that I don't want is no oranges. I know that's a double negative, but Sounds kind of silly. I don't want no oranges. But I don't want none of them to be orange. So I could find the probability of each of these, or what would be easier is saying I want everything except no oranges. All of them not being orange. That's the one thing I don't want. I want 100% of the options except this one option, not orange. So all of them not being orange would be 0.86, since orange is 0.14. Not orange is 0.86. And so I type that in my calculator. 1 minus 0.86 to the third. 0.364. 0.3639. So it's like saying, okay, all of my options are 0, 1, 2, or 3 oranges. I want all of these, and I want to take away 0. So I'm doing everything except no oranges. Okay. You're taking a multiple choice test, I guess, and you estimate based on your last test that you have a 60% chance of getting a question right. There are 4 multiple choice questions. What are the chances you get all of the questions right? So there are 4 questions, and you want them all to be right, and you said that there was a 60% chance you get them right. So 0.6 to the 4th is that 0.1296. What are the chances you get at least one right? At least one means I want one of them to be right, or 2 of them to be right, or 3 of them to be right, or all of them to be right. The one thing I don't want is none right. So I want everything except 0 right, meaning all wrong. So if correct is 0.60, not right or wrong is 0.40. Everything except them all wrong. I'm okay with getting 1, 2, 3, or 4 right. The one thing I don't want is none of them right. And I get that point. These are all multiplying, by the way. Assume that with dashes it means multiplying. What are the chances the first one is the only one you get right? So you got the first one right, but then you got all the other ones wrong. And you should get is 0.0384. Okay, gonna move on to the next page. I am randomly picking groups for class. There are 28 people in the class. 10 are girls and 18 are boys. So in this case, I'm given the whole population size, 28 people, and then I'm gonna pick a group of 4. So my sample is 4. My population is 28. That's a pretty small population. So because of that, I think I'm gonna use fractions. If I look at this, n, which is my sample size, 4, is not less than 4 is less than 10% of 28. 4 is not less than 2.8. So because of that, I can't just go ahead and do decimals. I'm going to have to consider the fractions because that probability is going to change. The probability is going to become dependent. So if I pick a group of 4, what is the probability? They are all girls. There are 10 girls out of 28. So if this is a girl, there's a 10 out of 28 chance that I could pick a girl. Now let's assume I got a girl that first time. Then there's 9 girls left to pick from out of 27 people. 8 girls left to pick from out of 26. Pick out that girl. And then 7 girls left out of 25. Notice that 10 out of 28 is 0.357. That's pretty different than 7 out of 25. which is 0.28. So the probabilities are changing, which is why we had to use fractions. So we're using these fractions here because we have this small population. If you're not given the population at all, like in the other ones, we didn't know how many Tootsie Pops there were, so we couldn't even decide. So in that case, we just have to assume that it's independent. But here we're going to use the fractions, and then I'm just going to type it in as I see it. So 10 divided by 28 times 9 divided by 27 times 8 divided by 26 times 7 divided by 25. Type it in just as is, and I get 0.010256, so 0.0103. Okay, if I pick a group of 3, so now I have 3 people, what's the probability the first pick is the only boy? So this one's a boy, it's the only boy, meaning these ones are girls. There are 18 boys out of 28, so the desired outcome out of the total is our probability of getting a boy. And then I've picked out that boy, so there are 27 kids left. And I haven't picked out any girls, so there are still 10 girls left. And then 9 girls left out of 26. Then again, I just multiply as I see it, 18 divided by 28 times 10 divided by 27 times 9 divided by 26. Don't need to do parentheses. I don't need to do each fraction separately. I'm just going to do it as I see it, 0.0824. Okay, if I pick a group of 3, what's the probability there's at least one boy? So that means I want 1 boy or 2 boys or 3 boys. The one thing I don't want is no boys. So I'm going to say I want everything except no boys. No boys would be all girls. This is the one variation that I don't want. I want every other possible variation. The one thing I want to take away is the possibility of all girls. So there are 10 girls. Oh, we already did all girls-ish, except there were 4 in that case. But probability of girl is 10 out of 28. Then I take away a girl, and I take away 1 from the pile. And I get this guy. And when I type this in my calculator as I see it, I get 0.9634. I should check my answers just in case, because maybe I could catch my mistake in this video if I have one. Nope, not yet. I rock. Okay, we're gonna keep going. 15% of Pritzker upperclassmen are in the IB program. 26% of upperclassmen are in band, and 9% of Pritzker upperclassmen are in both. Is being in the IB program and being in band mutually exclusive? No, it's not mutually exclusive. You can be in both programs. Mutually exclusive means there's nothing in the both section. This one has people present in here, so it's not mutually exclusive. There is a both. Mutually exclusive means that this area in here is empty, or you can completely separate the circles. What is the probability that an upperclassman is in IB or band? So I know that or means add, so there's a couple ways to do this. One is to be like, okay, I know from my rules that it means add, but I need to make sure I'm not double counting. So 15% are in the IB program, so that's 15% for IB, or 26% are in band, so I add, but there are 9% of people who are in both, so they're in this group and they were counted in this group. So I need to take away one of the times they were counted, and that gives me my probability. And I get that 0.32. Now I could also do this using a Venn diagram. I know that there's 9% in both. And so if I were looking at the Pritzker IB people, there's 9 in there, and in total this circle needs to be 15. I do 15 minus 9 and I get 6% who are in just IB. And then looking at this whole circle, I get the 15% that are in IB. Okay, and I do the same thing over here for band. I know that 26% are in band, which means that with the 9% here, I'm missing 17 total in this circle, because 26 minus 9 is 17. And now if I add across, that should give me my 32%. 6 plus 9 is 15. 15 plus 17 is 32. Okay, so either method works. You could use the formula or you can make your Venn diagram. What is the probability an upperclassman is in neither? So if there's a 32% chance they're in IB or band, neither, not in IB nor in band, would be the opposite. And so if I look at my Venn diagram, it's like the outside of these circles. So it's the complement of this 0.32. So I'm saying, okay, I want everything except these 32%. So 1 minus 0.32. And then what is the probability an upperclassman is in band but not in IB? So that's these guys over here. They're in band, but they're not in IB, so it's these 0.17. You could also think of it as, okay, I have 15% in band, but 9%, oh, sorry, I don't have my white out. I have 26% in band, but 9% of those people are in IB, so I could just subtract. All right. I'm going to move on to the next page and the final page. 5 girls and 2 boys volunteer to represent their class at a school assembly. The teacher selects one name and then another from a bag containing the 7 students' names. So again, the population is only 7 students, and it sounds like she's selecting 2 names. So 2 names out of 7, that's definitely going to need fractions. So I'm going to use these fractions. So the teacher selects one name and then another from a bag. So 2 names. And the question is, what's the probability they're both girls? 5 out of the 7 are girls. So the first time there's a 5 out of 7 chance you get a girl. Then you pull that girl's name out of the hat. You don't put it back. And so then there's a 4 out of 6 chance of getting a girl the next time, because there's 4 girls left out of 6 total names. So 5 divided by 7 times 4 divided by 6, 0.4762. And then both boys is similar. There's a 2 out of 7 chance you get a boy the first time. Then you take that boy out, there's 1 boy left, and there are 6 names left. So this would be 0.0476. And that's how we get that answer. 1 boy and 1 girl in any order. So I just want 1 boy and 1 girl. So it could be boy, girl, or it could be girl, boy. So that would be 2 out of 7. And then there's still 5 girls left, but there are only 6 names. Or 5 out of 7. There's still 2 boys left, but there are only 6 names. So, and whenever I see or, I should be thinking add. So I can just type it in as I see it. 2 sevenths times 5 sixths plus, it's basically the same thing. And I get 0.4762 again. There we go. 40% of CPS students take Spanish, 24% take French, and 7% take both. So this is what we see here. The probability of Spanish is 40, the probability of French is 24, and Spanish and French is 0.07. What's the probability you take only Spanish? Well, if 40% take Spanish, but 7% of those people also take French, what I want to do is take that 40% and take away that 7% who are in both. And I should get 33. Now I can also do this by making the Venn diagram. 7% take both. So if this is Spanish and this is French, Spanish is 40% total, which means that if I need this whole circle to be 40% and there's only 7 in it right now, I'm missing 33%. And if I need this whole circle to be 24 and there's only 7 in it now, I'm missing 17%. Okay. And then I can figure out what's on the outside, people who don't take Spanish or French, that's you guys. There's only 43% that take neither Spanish nor French. Either they're not taking a language at all, or they're taking something like Russian. You crazies. A lot of Chinese out there as well. Okay, so what is the probability you take Spanish or French? Well, you can either do it with the Venn diagram and just add across. You get that 0.57. Or you can say, well, it's the probability of Spanish, or meaning add the probability of French, but then take away the people who have counted themselves in both categories. So that's 0.64. 64 minus 7 is 0.57. What is the probability you take neither Spanish nor French? Well, if this is the or, then the opposite is the neither. So that would be 1 minus 0.57. Or you can think of it as the outside of your Venn diagram. This guy on the outside. Okay, last one here. I'm going to make my T-chart over here. 8% of students get A's. Remember, 8% is 0.08, not 0.8. 43% get B's. 35% get C's. 12% get D's. And the rest get F's. So I need to add all of these up, and when I add them up, they should equal 1. If they don't, it means that's the missing category here. So this is 51, 86, 98, so I'm missing 2%. Okay, so what percent get F's? That's my 2%. This whole thing is 98%, so 1 minus 0.98 gives me that 0.02. Okay, what is the probability of not getting an A? So that is everything except A, so 1 minus 0.08. That's the complement rule. What is the probability that a student chosen at random is an A or B student? A is 0.08, B is 0.43, and this is mutually exclusive. It's disjoint, so there really is no both. You can't be both an A student and a B student in a class. You either have an A or a B. You can't have both. So because of that, there's no both, so I can just add it as is. I can subtract 0 if I wanted to, but that doesn't do anything. What is the probability if I randomly choose 3 students? Now I have these 3 students. They are all B students. So this guy's a B, and the next guy's also a B, and the next guy's also a B student. So 0.43 to the third gives me that 0.0795. Okay, what is the probability that if I choose 3 students, they are all A or B students? Well, I know A or B from back here in C, that was 0.51, so I just have that 3 times in a row. And I do get this 0.1327. Okay, what is the probability if I talk to 3 students? At least one has an F. So that means out of my 3 students, I'm okay with one having an F. I'm okay with talking to 2 kids that have an F. I'm okay with talking to 3 kids that have an F. I just want to know what's going on. But I want to make sure that I'm talking to somebody who is failing so I can figure out what I can do to do better. So the one thing I don't want is no Fs. So I want everything except no Fs. So if F is 0.02, not F or no F would be 0.98. And so it's 1 minus 0.98 to the third. 0.0588. Good answer key for myself. Okay, and that's everything. So if you have questions, please email or set up a video chat.